Hence, what's the first thing you would do when you come across this number 12 by 6? We simply divide 12 by 6 and write the quotient as 2. Similarly, for the rational number 3 by 4, if you divide 3 by 4, the quotient would be 0 and the remainder would be 3. Now, if you further divide, the quotient will be 0.75 when the remainder is 0. So, 3 by 4 is equivalent to 0.75. Now, this type of representation is known as decimal representation. Now, consider two more rational numbers, 1 by 3 and 2 by 7. Let's see the decimal representations. 1 by 3's representation will be 0.33333 and so on. The sequence never ends since the remainder will never be 0. So, we represent 1 by 3 equal to 0.3 bar, indicating that the number 3 actually never ends. For 2 by 7, if we compute the division, the decimal representation will be 0.285714 bar. That is, this sequence keeps on repeating. Even for 2 by 7, the remainder never becomes 0 and the following sequence keeps on repeating itself. In the decimal representation of any rational number, you will find any one of these two patterns. That is, either the digits terminate or the same digits keep repeating after a regular interval. That is, the digits keep recurring. So we can conclude that the rational numbers in their decimal representations can be classified into two categories. The first one is the terminating decimals, where the digits actually end. And the second is recurring decimals, where the digits will not end but will repeat themselves after a regular interval. So, given any decimal representation, we can find whether it is a rational number or it is not a rational number. Now let's check our learning. Out of all these four decimal representations, which of them are rational numbers? In the first number, the digits 1, 2 are repeating. That is, they are recurring. So we can represent that number as 0.12 bar. So the first number is a rational number. Now in 0.123333 and so on, the only digit that is repeating is 3. So that number can be written as 0.123 bar. And the bar is only on 3 since it's the only number which is repeating. So 0.123 bar is also a rational number. And now in the third number, we can see that the digits are neither terminating nor recurring. So this number is not a rational number. Finally, in the fourth number, although the digits 1, 2 are repeating, they are not repeating at regular intervals. That is, this number cannot be represented in the form of some bar. So, this number is not a rational number. After understanding the decimal representation of the rational numbers, let's try to represent them on the number line in their decimal representations. Let us say we have to locate the number 2.3 on the number line. First, we will magnify the line segment between 2 and 3 such that we divide it into 10 equal parts. Now, the length of each part will be 0.1 units. So, this point is 2.1, this point is 2.2, and this is our required point 2.3. This is how we plot decimal numbers on the number line. Now, let's make this difficult. Let us say we have to locate the point 2.34 on the number line. We know that 2.34 lies between 2.3 and 2.4. So, we will consider the line segment between 2.3 and 2.4 and we will magnify it. Now, we will divide this line segment between 2.3 and 2.4 into 10 equal parts such that the length of each part is 0.01 units. Now, this point will be 2.31, this point will be 2.32, and here is our required point 2.34. Instead of magnifying twice and representing the number 2.34 on the number line, we can divide the line segment between 2 and 3 into 100 equal parts, where the length of each part is 0.01 units. Now, the points will be 2.01, 2.02, 2.03 and so on. So in this way also we can represent the point 2.34 on the number line. But this method is more tedious and takes more time. So it is always better to follow our previous method. Now let's see how we can represent a recurring decimal like 2.34 bar. But for this we need an additional information regarding the places of decimals. That is, if we are asked to represent up to 3 decimals, that is, if we are asked to represent the number 2.344, we have to divide the line segment between 2.34 and 35 into 10 equal parts. That is, we are magnifying further between 2.34 and 35. Now, after dividing the line segment between 2.34 and 2.35 into 10 equal parts, the length of each part will be 0.001 units. So, the points are 2.341, 2.342, 2.343 and here is our required point 2.344. Now, if we are asked to represent the same number 2.34 bar but up to 4 decimals, then we will magnify the gap further. That is, we have to divide the line segment between 2.344 and 2.345 into 10 equal parts, where the length of each part is equal to 0.0001 units. So, the points will be 2.3441, 2.3442 and here is our required point 2.3444. So, this is how we will represent the rational numbers in their decimal representations on the number line. So, we have represented both terminating decimals and also the recurring decimals. The most important thing that you have to understand is the decimal representations of the recurring decimals cannot be represented on the number line exactly, because we need the number of decimals to represent them. So it's better to convert them into P by Q form, since we can represent P by Q form exactly on the number line. And that's what we will be learning in our next video. As of now, let's summarize what we have learned so far. Rational numbers in their decimal representations can be classified into 2 categories. One is the terminating decimals and the other is the recurring decimals. In terminating decimals, the digits are finite. In recurring decimals, the digits are infinite, but they keep repeating themselves after a regular interval. To plot the recurring decimals, we have to keep magnifying the number line based on the number of decimals.